Alright, so solving quadratic inequalities. Now these do come up sometimes, okay? These are really enjoyable.
No.
Now, here's the deal. This is where we need to remember, she says very importantly, all about quadratic graphs.
Yes.
Okay? What kind of graphs are quadratic graphs? We solve them by putting them equal to 0, but what kind of graphs? If we were to see a diagram of them, what would they look like? Try not to shout out. Let's get some more involvement. Yes. What's that kind of thing? Oh, we've got some words being shot out. Okay? We've got some swooping in the air, and we've got some parabola words. Do we remember they kind of look like this? Or like this?
Oh, they're parabolas.
Yeah, that's what Lex said, and I kind of commented on that as well. Good, good. Emma was listening, obviously. Just to clarify, that was Emma. Right, so quadratic graphs look like this, yes? These are positively happy ones, so that's when the number in front of the x squared is positive. These are negatively sad ones, it's when the number in front of the x squared is negative. Yes, remember that? Alright. Our basic x squared graph looks like that. Oops, and it goes through the point 0, 0. Yes? So this would be what our x squared graph looked like. It goes through the point 1, 1 to what? No.
4.
Think about it. Yeah, 4, 3,
9.
and so on and so forth. Yes? What feature do they have? They are symmetrical. Lovely. What do we describe this point
The
as?
minimum point.
Minimum point or the vertex. Love it. All flooding back to you. So if this is our normal x squared graph, what would the graph that said x squared minus 4 look like? Now this is transformations of the function. What does this number, the minus 4, do to this original graph? It doesn't make it sad. That would be if the negative went in front of the x squared. It moves it. Has it?
Right.
Changes the y-intercept. Yeah, at the moment the y-intercept's at 0. Where will the y-intercept be? Okay, so it shifts it down, 4 units, yes? To negative 4. You all happy with that? Oh, yeah, because the whole graph just shifts down. The movement left and right would be when it's in a bracket, okay? Remember that it goes to the opposite value, so that one there would actually cause a positive 4, okay? Are we kind of remembering this?
Yes.
Yeah? Okay, so if we are happy, then we could say that this graph, x squared minus 4, is less than 0. Okay, I'm actually going to retreat. No, I'm not. I'm going to stick with it. Okay, so this is minus 4. Okay, so this is my graph of x squared minus 4. It's a little sketch. It's like a terrible sketch, but it'll do. Okay. Now, we want to know where that graph is less than 0. Okay? Where is that graph less than 0? So what we need to do is to say, I need to identify the range of values for this. Do we understand that? Because that's less than 0. Yes? So it's below the x-axis. Yes? Okay? So this is my x-axis, this is my y-axis. So my graph here is less than 0 in this portion here. Okay? So in order to identify these parts, I need to know these two values. Okay, so what I need to do is to find out where it crosses the x-axis. So I can do that by rearranging solving this. So I would say x squared minus 4 is less than 0. X squared is less than, or actually let's stick to because we're finding the places we would say is equal to 0. So x squared is equal to 4. What do I then do to find x? Square root 4, which is, remember, plus or minus 2. Okay? Which means that hopefully you're comfortable with it. This value must be a 2, and this value here must be a negative 2. Yes?
Oh, so you literally just solve?
So we literally just solve it because we want to find out where it is equal to 0. So we need to find these 2 points. Well, our graph is less than 0 between those 2 points. How do we show a range? We say that x is in the middle. We put our inequalities always facing left. We put our most further left number on the left. And we put our most further right number on the right. Now, had this marking here be or equal to, we would have included the or equal to. Okay, but it doesn't in this case, so we would just leave it as those 2. That's it. That's all we have to do.
So you just solve that?
Just solve it because we need to establish what these 2 points are.
And then literally put it inside.
And then have a look. Now, I don't want to confuse the situation, but if the question had been x squared minus 4 is greater than 0, okay? Same deal. Here's our graph, la la la. This is negative 2, this is 2. Where is it greater than 0? Well, it's going to be here or here, yes? So the same principle, we'd have to do all the same working to find these 2 values, but it wouldn't be a range of values like this. This one would say x is less than negative 2 or x is greater than 2, because these points here are less than 2, these points here are greater than 2. Do you see that?
Yeah.
Yeah? So, if it's underneath, a range. If it's above, it's generally going to be 2 separate ones. Okay? We can't combine these together into 2 separate ones. Okay? That's pretty doable, yes? Lovely, lovely. Have we all got that down? Thank you. You a bit sleepy? You were here then.
How do you know that it's like positive instead of
Because it was
the other
a
way?
positively happy parabola.
So what would it be if it was negative?
It would be
just-
upside down.
No, but would it just be negative x squared or?
Oh, no, it would be, I think we're going to do, I think one of them ends up being a negative. So I'll show you in a second, I think. Is it or not? Hang on. Yeah, this one's a negative one, so I get to show you that. Okay. Can I do what, sorry? Okay, so this red one is not the actual question, just to remind you. So the blue one is the actual answer for this particular question, but if it looked like that, it would be that. All right, similar kind of thing here. However, we haven't got a nice straightforward just x squared plus or minus something. What do you think we might have to do to this expression to help us?
It's like doing
Rearrange? What did we do with this bad boy? We actually solved that it was equal to it, yes, to find these 2 numbers. So what are we going to do here? We're going to solve this one. We're going to try and find the values that would make it equal to 0. So first of all, we're going to solve x squared minus x minus 2 equals 0. What should be, ideally, in this world, the quickest way of doing it? Ideally,
Oh, it's a, like, they put it into 2 brackets and then say both equal to.
yeah, when we're putting it into 2 brackets, what's that process called? Factorizing. Okay, so ideally you're getting confident and competent and speedy at factorizing quadratics. So I'm trying to factorize this. I don't know what's wrong with the board.
Is it minus 2 and 1?
Yep, so I'm going to have minus 2 and positive 1. Yes, because these two numbers multiply to give negative 2 and add to give negative 1. So what that means is that if I were to sketch this graph, I'm going to cross it at positive 2 and negative 1. You all happy with that? So negative 1, positive 2. So drawing a little sketch of it, I feel, always helps. Is this a positively happy quadratic or a negatively sad? Positively happy. Okay? Doesn't matter where any of these other points are, where it doesn't matter where the vertex is, it doesn't matter where it crosses the y-axis.
But how do you know it's happy, right? Because there's nothing in front of it.
Because
it's positive.
it's a positive value here. Yeah.
Wait, what is it oh, the x
In front of here. Yeah.
Wait, would it ask you to draw a diagram?
Unlikely for these. Possibly, but
Because then, like, I know you know where the 2 and minus 1 is, but where would you put the vertical?
okay. Well, so let's discuss this. How do we find? Because this is a question that was in one of the assignments. How do we find this point here, where it crosses the y-axis?
Is it vertex?
I know I'm doing two different things. It's the y-intercept. So what do we know about the y-intercept? Y. It's when the value of x is 0, yes? So to find the y-intercept, we would substitute the value of 0 into here, in both of these positions, and we'd see that that was negative 2. That's not the vertex though, okay? The vertex is always going to be, because it's symmetrical, it's got to be halfway between these 2 points, yes? Do you remember that? So this is 3 units worth. So how many units would be halfway? 1.5 units away. Okay, so we'd say what's 1.5 units away from here, or 1.5 units away from here? 0.5. And so what we would do is we'd say that our vertex is at the point 0.5, comma, how do I find this tip? You substitute this value into here, yes? So you would substitute the 0.5 into here, these two positions, and work out what the y value
Wait,
is.
why is it not minus 2?
Because that's where it, no, my diagram's rubbish. Okay, you have to remember that mine's rubbish. So it's a sketch, because in this question we haven't been asked to establish these things. This is a side step into other questions, okay? But that's what we would do to find the vertex. Yes, Lena?
Why did you switch the signs of the 2 and the...
Because remember, when we're solving a quadratic, either this bracket has to end up being 0 in order for things being multiplied together and answering 0, or this bracket would be 0. If this bracket was 0, it means that the value of x has to be 2, because 2 take away 2 is 0. So that's where you say x minus 2 equals 0, rearrange this, x equals 2. This one would be x plus 1 equals 0, this would be x equals negative 1. Okay? So, and that's because when you're multiplying things together, one of the brackets has to equal 0. Okay? Now we've completely digressed. But here's our diagram. It's positively happy. Our points here are negative 1 and 2. We're trying to find out when that graph is less than or equal to 0. So whereabouts is it less than or equal to 0? This bit here, yes? Underneath the x-axis. That's in between these two values.
Wouldn't it be the x-axis as well?
This time, yes. Okay, so it's in between these two values. So we've got x in the middle, point R, inequalities left, negative 1 and 2. But because it's all equal to, we add those two bad boys there.
Wait, why is it not like the top one side that's when we did before? Like where it's plus 3? Oh,
Because that was just a one number.
Okay.
Okay, so for this one it was a more complicated quadratic. It wasn't just the same number left and right.
So what exactly is the range part?
So it's between the -1 and 2.
So what if it's... Okay, it's 3 and 4. Okay, yeah.
Huh? Yeah?
That's fine.
Are we good? Bored already?
Yeah.
Love it.
So wait, why did we highlight the stuff at the bottom?
Because it says less than or equal to 0. So if the graph is less than 0, it means it's underneath the x-axis. That's not convincing.
Yeah. No.
So your graph has to be less than or equal to 0. Here, what's the value of my y here? Is that positive? Okay. What's the value of my graph here?
That was negative.
Negative, which is less than 0.
Oh, got it.
Are you with me now?
Yeah.
Okay, good.
Oh, okay.
Oh, pennies dropping all over the shop. Yeah? Next one. What we can do with this bad boy? Tablets first. Factorize it.
Or you can do these.
So we're pretending that it's equal to, we're solving that, or you can use quadratic formula. So we're looking for two numbers that multiply to give +6 and add to give -5. Minus 2, minus 3. Love it. Okay, we know that they both are the same sign because the end number is positive. We know they are both negative because the middle number is negative. Okay, so that means that our two values are +2 and +3. Draw a little sketch. Oh, what's this? So here's 2, here's 3. Is this a positively happy or negatively sad? Positively happy. Again, it really doesn't matter what our sketch looks like. We then look at what they've asked us to do. This time it has to be greater than or equal to 0. Okay? So which parts of the graph are greater than or equal to 0? Hopefully you can see it's this bit or this bit. Tanya, you good with that now? Is that convincing?
Yes.
Or I'll just say it to shut her up.
No, I got it.
Good. So this time, are we going to have a range? Is it between two numbers? No, this time it's two separate portions, okay? Because we're talking about these values or these values. So we would say x is less than or equal to 2. X is greater than or equal to 3.
Between negative and positive.
Yes.
Negative and positive.
Because if it's in between, we scooped between those two numbers. But here it's these ones, which is less than 2, or these ones, which is greater than 3.
So are those written together? Or
No, they would be, so you have to have both of them as your answer, but there's no way you combine them. Okay, so it's not a nice, pretty range like we've had in the past. It's two separate branches.
So as
Let's do. Yep, greater than or equal to 3, or it can be less than or equal to 2. You must have both of those portions there to actually answer
How do
the
you know it's
question.
negative is sign? Like, I know one is greater and one is less. I don't see how you know.
Because here, it's on the left of the 2, so that means less than 2. Less than 2.
It's not just like straight up.
No, because remember, to get this point here, it would be this value, whatever they. Yes? Does that make sense?
Yeah. And x represents the line.
So x, we're talking about these values. Which of these values here are we interested in?
Okay.
Okay? And then this is our last example. Okay? So, how would I solve this bad boy? Okay, I might personally, first of all, take the negative sign to the front, and I would have x squared plus 2x minus 5. Okay? The reason being is it's way easier to deal with the negative sign at the front. I haven't got rid of it, it's still there. But that means that both of these two signs have changed. And I've just written it in the order that we're used to seeing quadratics.
Wouldn't it be +5 inside the bracket?
No, because this is a positive 5, and so because I brought the negative to the front of everything, all the signs have to change.
Okay.
So if I were to expand this back out, knowing this is a secret -1, I'd get back to the signs that I had at the beginning. Yeah?
You can't just have to rearrange it.
You can't just rearrange it. Do you mean to the other side? Hang on. To the other side of the inequality? You could do. Yeah, that's your other option, but you may come into tricky territory if you do that. So what do you think?
Isn't it like why in the mark?
Because to factorize something, I prefer to have a positive x squared. Otherwise, it's a bit more challenging to try and factorize. Like that. You know when you say that, I can't say.
Without -1.
No, the negative has to be there because we have to know that it's a negatively sad quadratic.
And then we can put it into the...
Okay, so,
Wait, but doesn't that make it a positively sad quadratic?
no, because this negative is still here, it's still part of it. Okay? Oh, we can't multiply numbers to get -5. Oh, that's a
So why does it...
daft question to choose, isn't it?
Just use the calculator?
Wait a second. You said that you wanted a positive x squared, right?
Yes.
So then how does it become just change the y? You want it. So how does it become sad if it's positive? And in the question it's negative?
Okay, so with any kind of maths, any kind of thing we do, we can rewrite the question in a different format to make our lives easier. Okay, so it's easier, rather than look at this and try and factorize it, it's easier if this is a positive value. Okay, so if we want to rewrite it to make our lives easier, we must not change the original question. We can rewrite it in a different way. So what I've chosen to do is I've chosen to put a negative sign at the front, and now everything else in here has changed its sign, but this question is exactly the same as this question. It's just written in a slightly different way.
Okay, so the x squared is still negative.
So the x squared in reality is still negative, but in order to work with it, it looks like it's positive.
Okay.
Yeah? Shall we change this? What can we change this to be?
Before.
Why don't we just leave it
We could.
So let's just do it.
Why don't we practice the competitive?
We could, but it's just, it makes it way
I
harder.
already have the answer.
Okay.
If you want
No, but let's, well,
No, let's not, because I don't even know how to use algebra.
what can we
Can
change?
you algebra problem?
Here, let's change that to an 8.
We can use one.
Let's do 8. Let's do 8.
But what if that was the question?
Oh,
Just use the.
but then you would just use the quadratic formula. It just would be a decimal. You want to stick it to, you want to keep to 5?
Wait, I don't even know what that is.
2 plus minus 3.
Alright. Okay, so Alex, start on a fair comment. If in an exam it is like this, all that would happen is that these numbers here we're having here, it would be a decimal number. Okay? I just think it's just a
You put it into a quadratic.
You would use a quadratic formula to find them.
A, B would use
Yes, exactly. So you would have the quadratic formula, or you can use the graphing calculator to help you find those two
And then
values,
it will give you.
but they would just be decimals. Okay, so that's the only difference, and that's the only reason I'm changing it here, because decimals in our notes is just a pain in the butt. But the process is what you need to worry about. The process is going to be exactly the same, no matter what the numbers are. Okay? Yes?
Okay.
Alright, so having changed it to this, which two numbers multiply to give -8 and add to give 2? -2 and +4, yeah. So when sketching my graph, I know I'm crossing at +2 and -4. So here's my -4, here's my +2.
It's not a negative sign in the front.
Yes, and that's what I'm going to say now. What does that negative sign in the front do to our graph?
It
It makes it negatively sad. So this time it does that.
What?
Okay? So we want our graph to be less than 0. So we're talking about this bit and this bit. Okay, so as you can see, this time the range is above the axis. Okay, so here we're going to have two separate portions. So we've got x is less than -4, x is greater than 2. And they are just the less than and greater than because of the original question. Excuse me, if you kept to the original 5, as I said, these would be decimal numbers. What were they, Amy?
-3.45 and 1.45.
Wait, so you wouldn't need to do the quadratic equation, right? You could have done it that way, which this would have been
You wouldn't have.
You can't factorize something when it's there.
Oh yeah, because
What
it
about-
can't go into it.
What about splitting the middle?
Splitting middle term, no, that wouldn't have worked either. That's only when we have like a 2x squared. Yeah. Okay, so if they're not whole numbers, you have to use quadratic formula or solve it from that graph. Okay? Do we all understand the concept there of solving quadratic? Yes? Yeah. Okay, Trisby Anns. Oh, we are